So we've already figured out that to find the distance travelled on a velocity time graph, you have to find out the area underneath. Now we've got a problem when it comes to finding the area under a curve. We know how to find the area of polygons, so that's what we're going to do. We're going to turn this curve into lots of polygons that we can find the area of. Now I'm going to enlarge this graph so that we can properly zoom in on it. Before I do so, if I read the first question, it says, work out an estimate for the distance travelled over 6 seconds. Use 3 strips of equal width. So I need to make sure I'm splitting my graph into 3 equal strips. Okay, so I've got my graph here. I need to split it into 3 equal strips. So I've got 6 seconds in total, so if I split that into 3, that's going to be 2. So every 2 there's going to be another strip. We try and be as accurate as possible with my lines because we're going to be using it to draw and find areas in a second. Okay, so now I'm going to turn those strips into polygons. So I've now turned them into polygons. I've just gone along the lines but put straight lines instead of the curved lines. I'm now going to split them into triangles and rectangles, which are easy to find the area of. Before I even try to find the area of the triangles and rectangles, I'm going to just mark on the points where the triangles' velocity are because they're at difficult points, so I want to figure those out first. So the first thing to think is, well, what is each little square worth? Well, if one big square is worth 2, and there's 5 little squares there, so 2 divided by 5 is actually going to be 0.4. So each little tiny square is worth 0.4. So this top triangle here, that's 1 square above 12, so that's going to be 12.4. And the one here is 1 square below 12, so that's going to be 11.6. And then I've got this one here. So that's 2 squares below 10, so 10 take away 0.8 can be 9.2. So I've worked out the fiddly bits. So now let's start working out the area. Okay, so area of this triangle here, and we're going to have, I'm going to do this in green, we've got a base between 4 and 6, so that's a base of 2. We've got a height from 4 to 9.2. So area of triangle is base times height divided by 2. So that's 2 times, I'm not even going to bother doing it, 2 times 9.2 divided by 2 is just going to be 9.2. I'm going to put that down the side because we're going to need that in a minute. Then we've got this rectangle here. Area of a rectangle is base, 2 to 4 is 2, times height, again 9.2, so 2 times 9.2, which is going to be 18.4. Then we have this triangle here, and we've got a base of 2 again, a height between 9.2 and 11.6. So I'm just going to work that out. 11.6 take away 9.2 is 2.4. Area of a triangle, base times height divided by 2. 2 times 2.4 divided by 2, we're going to end up with 2.4. So let's put those numbers off. 18.4 and 2.4. So that's all our areas so far. Next up, we've got this rectangle here. Again, 2 across. And this time it's going up to the 11.6. It's going up to this line here. So 11.6 up. 2 times 11.6 equals 23.2. And then we've just got that last triangle here, a base of 2 again, and a height between 11.6 and 12.4. So 12.4 take away 11.6 is 0.8. So if I just redraw this triangle here, I've got a base of 2, height of 0.8. Again, base times height divided by 2, I'm going to be left with 0.8. Okay, so I found out the area of all of my polygons, so I can add those all together to find out the area under the curve. So I've got 9.2 plus 18.4 plus 2.4 plus 23.2 plus 0.8, and I get 54. So the distance is 54 miles. Now this is only an estimate, and part B of the question was, is it an underestimate or an overestimate? Now you can see that this is clearly an underestimate because there's a lot of the curve that we've missed out. So we've missed out all of this bit here. We've missed out a tiny bit here as well. So it's actually an underestimate. So part B, the answer would have been underestimate.